having reaction with concentrated sulfuric acid, and this reaction, it is temperature dependent. So meaning if you dehydrate the alcohol at 0 degrees, you are going to form a sulfonate. At 180, you are going to form an alkene. At 140, you are going to form an ether. So let's look at this reaction. You are having ethanol in presence of concentrated sulfuric acid. The temperature range is 170 to 180. And what is going to happen? We shall have dissociation of our sulfuric acid. Aqueous. It's going to dissociate. We are going to use reversible arrows. It's going to form a proton plus also 3H. There. So we are going to have our alcohol here. And we are having also our. So this alcohol, the oxygen is going to donate electrons to our electrophile. And we are going to have, say, 3. So we are going to form water, which is positive charge because oxygen will be having excess bonds. But remember now, I can write it in this case. And have hydrogen there. Then this is our water. So we are having this nucleophile. So what it's going to do, it is going to attack this hydrogen, and this hydrogen is going to bring back the bonding electrons here, and it's going to form a double bond, a beta leaving group. The OH is made a beta leaving group, so it can easily go in solution. So you're having minus water, and you're going to form CH2, double bond CH2. Now we cannot lose water here, and we form CH3, because this carbocation is very unstable. So we are going to follow this reaction where we are having, this is going to be elimination by molecular. Because we are having two species, we are having this one attacking and the other one is going. Return one all, and we are dehydrating it at using concentrated sulfuric acid at 180 degrees. At this point where we have this water plus, this water is going to break off, and we are going to form this primary carbocation because there is a provision of stabilizing this carbocation. It's going to be turned into a secondary carbocation by a process we are calling hydride shift. So in hydride shift, it means this carbon, this hydrogen is going to move with a charge to this carbon here. And what is going to happen, we shall have CH3, CH2, and this is going to be in C. It's going to be with the charge. Then this is going to become CH3 in this case. So I think you are seeing the position of the carbocation. It was here, it was primary, and at this stage it is secondary. Plus CH3. So remember, it's having a charge, but the lone pairs are available. They can donate electrons there, and this bond is going to give its electron here to be bonded between this and this carbon, and they are going to form CH3, CH, CH3. So in this case, I think we are seeing we are forming but2 in instead of but1 in because of this hydride shift which happened. At 40 degrees, we are going to form an ether. This is called an ether. Hypoctane is going to be ethane. And this is the mechanism. So at this point, when we form this water plus, remember we are having 2 molecules of ethanol. Another molecule of ethanol is going to come. It's going to attack this carbon, and this bond is going, this water is going to go off. Then say minus water, and shall end up with CH3, CH2, and this is our oxygen from here. I'm displacing this hydrogen, and CH2, and CH3, and this is going to be plus. So we shall have minus a proton. One proton is going to go off, say CH3, CH2, and they have formed our ether. Remember, this is not an ester, it is an ether. So at 0 degrees, we are going to form a sulfonate. And the sulfonate, after this dissociation of sulfuric acid, shall have a proton being attacked. We shall have oxidized water plus. Then shall have our sulfonate. It's negatively charged, and this is CH3. So it's going to attack this carbon, and this water is going to go off. I shall end up with CH3, CH2, and we have obtained our